Okay, okay, we can start. We can start.
Okay. So, dear students, you are welcome to the presentation of the master program, International Master Program on the Department of Mechanics and Mathematics of Moscow State University. This program is called Geometry and Quantum Fields, and it is aimed to the presentation of modern courses, especially in quantum field theory and related topics. Also, students who will enter this program, they will be able to take courses in several modern directions of mathematics, such as geometry or spectral theory of operators or something like that. So you are welcome to this program. It is a new program. It is started just this year, and we hope that the program will be quite successful. Now, I would like to ask Maxim Grigoriev to say a few words in more details about the program. Thank you.
Okay, thank you. Hi to everybody. My name is Maxim Grigoriev. I am a deputy director of the Institute for Theoretical and Mathematical Physics. So the program is joint. It was developed by people both from Department of Mechanics and Mathematics and our institute, and it reflects the interdisciplinary nature of the program. So now let me share my screen to show few slides about the program and the institute. Does it work? Do you see the screens? Do you see the slides? Can you see the slides?
Yes.
Okay, very good.
Sure.
Okay, so as Professor Shafarevich has already told us, this is an international master program. It's taught in English language and meant for international students, but also including Russian nationals. This is a course in mathematics and theoretical physics. From the point of view of physics, it focuses on physics and of fundamental interactions, with a certain emphasis on quantum gravity, which is a probably most challenging theoretical and probably mathematical problem in this area. And the very unique feature of the program is that it combines mathematical courses, first of all, courses in geometry, with a systematic education in quantum field theory, gravity, string theory, holography, and related topics. So all these are often referred to as a modern theory of fundamental interaction. The program also includes an individual research project, which is going to be supervised by leading researchers from Moscow State University or other research institutes in Moscow. Again, because the program is quite interdisciplinary, we have two leaders. So Professor Andrei Shafarevich, who already said a few words before, and Professor Arkady Tsaitin, who is the director of Institute of Theoretical and Mathematical Physics, and he's a very well-known theoretical physicist working in this area, in the theory of fundamental interactions. Okay, as I already said, the concept of the program is to combine a solid background in mathematics with a systematic education in physics. Why it is important and interesting? Over many years, we saw the fascinating development of these areas of physics, so this area of fundamental interactions. But despite this, we still have a very important conceptual problems open including the one of quantum gravity, which I already mentioned, the problem of dark matter, etc. From the very early days of the development of this of the theory of fundamental interactions, it was clear that there is a very deep relation and the mathematical and the mathematic between these areas of physics and mathematics, and in particular and most of all with geometry. For instance, the very well-known Einstein gravity operates in terms of Riemannian and Cartan geometry. More recent developments, such as the theory of gauge fields, corresponds to theory of fiber bundles, and gauge fields correspond to connections in fiber bundles. This is very further developments showed up a deep relation between these gauge theories and theories of characteristic classes, homological algebras, and other areas of modern mathematics. And even more close is the relation between the modern attempts to describe fundamental interactions in terms of string theory and many areas of mathematics. These include a theory of Riemann surfaces, infinite dimensional algebras, conformal geometry and commutative geometry, supermathematics, mirror symmetry, etc. Then this list can be continued and continued. But these developments, these interrelations, they also go both ways. So it turned out that the ideas and methods which originate from quantum field theory turned out to be very interesting, and they led to new developments in mathematics, and there can be many examples of this as well. So I hope that these points justify the importance of a interdisciplinary education in these areas, because you never know where the new interesting developments are going to happen, either from math or from physics side. Okay, although it's a very challenging task to put mathematics and physics together within one program, we believe that this is worth the effort because of the reasoning I've just given. In this program, the students will have a unique and broad education, obtaining a good starting point for their academic career in both mathematics and physics, or for a career in more applied areas, including industry, where the ability to think independently, creatively, and originally is an important condition. As we have already mentioned, this program is a joint program between Faculty of Mechanics and Mathematics and the Institute of Theoretical and Mathematical Physics. So let me say a few words about the institute. So it's relatively new. It was established in 2018, but started to work in 2019. It's a research center within Lomonosov Moscow State University. It is actively involved in teaching in both mathematics and physics, and it is quite international. Most of our positions are filled by the open international calls, and ITMP researchers are involved in teaching and serve as advisors for the diploma projects of our students. It has an international, creative, and friendly environment, and at the moment, we have around 10 researchers and lecturers working in the institute, some international postdoc fellows, about 10 PhD fellows of different type, and some associated members, which are researchers, well-known researchers from other institutes in Moscow and Moscow region, who take part in teaching activity of the institute, or and participate in some research activities such as seminar, etc. They can also serve as possible supervisors for diploma theses. And I also already mentioned our director is Arkady Tsaitlin, who is a very well-known theoretical physicist. Okay, and few words about the program itself. The courses of the program can be divided into, roughly divided into 4 groups. So the first group is the basic courses in math, including courses in geometry, algebras and representations, functional analysis, conformal geometry, etc. Then there are basic physics courses. First of all, quantum fields, general relativity, string theories, superstring sigma models. Then there is a group of interdisciplinary courses. These are the courses which can be qualified as mathematical physics courses in this area, and they can be interesting from both sides. They can be considered as both mathematical and physical courses, and these include mathematical theory of black holes, quantum integrable models, topological theories, Batalin-Vilkovisky quantization, two-dimensional conformal field theories, etc. And there are some advanced courses which are devoted to rather modern areas of research, still actively developing. And these courses are meant to help students to catch up with the modern research in these areas of mathematical physics. And these include some courses on conformal theory and holography, Seiberg-Witten invariants, theories of higher spin fields, geometrical theory of partial differential equations, and some other courses. Here are some, very briefly, let me go through selected courses, just to mention their exact names and the names of the authors. It's most of the people mentioned as authors are going to actually teach, but not all. It's for some courses, it's not yet decided who exactly is going to teach, but the authors are here. So speaking about basic math courses, there will be a course in theory of Lie groups, Lie algebras, and representation in the representation theory, including finite and infinite dimensional. There will be a course on differential geometry, systematic course on differential geometry and topology, systematic course on functional analysis and the theory of operators, course on conformal geometry and Riemann surfaces, and a course on homological algebra. Then in physics, we are going to have 2-semester systematic course on quantum field theory. Then the course on string theory, also 2 semesters. Course on general relativity and selected topics of general relativity, and a course on superstring theory and sigma models. Speaking about interdisciplinary courses, so we have CFT in 2 dimensions. We have topological quantum field theory, mathematical theory of black holes, Batalin-Vilkovisky quantization, introduction to supergeometry, and a course on symplectic geometry and quantization. And speaking about advanced courses, here are also some names, among which, for instance, conformal field theories and holographic dualities is devoted to rather actively developing research area of ADS-CFT correspondence. Also, quantum integrable models is an actively developing research area. Let me also mention higher spin theories and holography. This is also actively developing area. Actually, all of them are devoted modern and actively developing areas of research. Okay, I think I am done. Thank you very much for your attention. And if there will be questions, I will be happy to answer those which are related to my presentation. Thank you very much.
All right, I guess, Maxim, I will be taking the spotlight now. Dear attendees, my name is Anna, and I am the manager of education projects of the Institute for Theoretical and Mathematical Physics. And I'm also a curator of this international master's degree program, Geometry and Quantum Fields. In my presentation, I would like to cover two important issues. The first one is the admission to the program, and the second one is the student support scheme. So allow me to share my slides as well. Here they are. Okay. So the first, I will be talking about the admission to the program. Admission to the program is conducted in two waves. The winter admission is aimed at the international applicants. For those international students who are graduating and prefer to apply to the program earlier within their final academic year, there is a winter admission that falls between November 15th and February 15th. There is also a summer admission period for international applicants, Russian nationals, and certain categories of foreign nationals who have a right to be admitted to state-funded places. Among those are the citizens of the republics of Belarus, Kazakhstan, Kyrgyzstan. The summer admission period falls on mid-June, June 15th, and runs until almost end of July, July the 20th. So all applicants to the program are advised to send their documents online to the admissions office at admissions@itmp.msu.ru. You may see the address stated at my slide. I would like to, all interested parties, I would like to bring your attention to the official web page of the program. You may see the URL address at the lower right-hand corner of my slide. The information stated at the web page of the program covers such important topics as the list of documents required to apply, the list of language testing systems the university and the program accepts in order to prove your language proficiency, as well as very important information regarding legalization and nostrification of your international academic diplomas and transcripts. Also, for those students who are planning to apply next year rather than the upcoming summer application period, I would like to draw your attention to the Universiade Lomonosov, which is a subject-specific competition organized by the Faculty of Mechanics and Mathematics every spring around March and April. The competition is divided into 4 sections spanning from geometry and quantum fields, the eponymous section of our program, as well as competition in mechanics and mathematics. It is an international competition, and all the laureates and winners of the competition will have benefits upon the admission to the program. So everybody who is interested and planning to apply next year, please do check out the Universiade at the official webpage of the Faculty of Mechanics and Mathematics. I would also like to touch upon student support system. So within the framework of the program, there are several student support initiatives. The first one is the financial aid. So the Theoretical Physics and Mathematics Advancement Foundation BASIS offers a funding scheme for international and local students who are incoming to the program. So the scheme supplies 10 grants for the duration of the program and 10 monthly stipends spanning between 30 to 50,000 rubles for student. Each student is advised to state their need in financial support during the application period and fill in additional documents for the application and send the financial aid application together with the application package for the program. In case you have any questions regarding the eligibility for the financial scheme and duration and how to apply, please do contact the Institute, and namely me. You may find the contacts of the curator at the web page of the program. I will be very happy to answer all your questions regarding financial aid and student support. Another support initiative is the opportunity for all incoming international students to abode at the MSU student dormitories, which are very comfortably located around the city, not far from the campus. And the third initiative is the full administrative support of all incoming international students by the administrative staff of the Institute and the faculty. All students will be met with qualified staff who helps with the integration within the academic process, all ongoing academic issues within the course or registration, as well as the full visa support. Thank you very much. I am going to finish my presentation here. And I would like to pass the spotlight to our colleague from the Faculty of Mechanics and Mathematics, Lyubov, who is going to talk about the summer school at the Faculty of Mechanics and Mathematics. Thank you for your attention.
Anna, thanks a lot. Let me also show my slides. So let me also welcome all our attendees today. And today I'm going to tell you about the summer school in mathematics and mechanics. That's a short-term educational program, which will be held by the Faculty of Mathematics and Mechanics in this summer. So the summer school is a provisional preparatory program to the master's program of the Faculty of Mathematics. I'm sorry. The summer school is a provisional program to the master's programs of the Faculty of Mathematics and Mechanics. And it includes 2 educational tracks, one of which corresponds to the master's program, Geometry and Quantum Fields. This school is aimed to acquaint our pre-masters. It is aimed on the bachelor students and graduates. So we welcome not also those students who have completed their education and received their bachelor diploma, but also we welcome 3rd or 4-year students of any bachelor programs. The school includes 18 academic hours of classes. So that's 8 academic hours of specialized training, 6 hours of preparation to the master's entry exam, and 4 hours of mock entry exam. This school precedes the second master's entry exam. As Anna said, the summer admission lists till 20th of July. So the school ends 10th of July, and the attendees of the school may enter the summer admission. The school is aimed to serve as primary acquaintance with scientific branches, lecturers, and potential advisors to master students, and will be completely online in English. So you may participate in the school just from your home or even vacation. The school includes 2 educational tracks. First of them correspond to the announced master's program and is headed also by Andrei Shafarevich, Dean of the Faculty of Mechanics and Mathematics of Lomonosov Moscow State University. And it will cover some basics of corresponding fields of science. That's modern differential geometry, quantum mechanics, and mathematical physics. This program will be taught by both specialists of the Faculty of Mechanics and Mathematics, as well as the employers of Institute for Theoretical and Mathematical Physics. The second program is Algorithms of Aided Inertial and Satellite Navigational Systems, headed by the head of a Laboratory of Navigation and Control of Lomonosov Moscow State University, Andrew Golovan. It includes some theoretical basis and applications of modern inertial, satellite, and aided navigational systems, as well as some information about the parameter estimation methods. As I said before, the school includes 3 activities. First of all, that's specialized training, which comes in 8 academic hours, including lectures and practice. The particular distribution depends on the track and will be listed in the school website till the 15th June. The specialized training is a complete introductory program in the corresponding domain and a possibility to acquaint with potential scientific advisors to the master's program students, as well as with the lecturers of this master's program. As you know, in Lomonosov Moscow State University, we pay a lot of attention to the scientific part of the programs. So we will also be happy to present so-called mini-conference in program of this school to see some scientific potential of the attendees of the school. A mini-conference is a short closing part of the summer school. It comes in addition to the specialized training, and it is the possibility of the school attendees to present and discuss with lecturers and potential scientific advisors your scientific report, which is in your own results, maybe some primary results, in addition to the possibility to discuss your report with lecturers. It may be also a nice preparation to the next year's Universiade Lomonosov. Surely the report is not a required part to participate in the school, that's just a possibility. The second part, which is compulsory, is the mock master center exam. The school, in fact, starts with the mock master center exam. And this exam is identical the trial exam. So it includes the set of problems with the same structure and difficulty level to the master center exam. And the results of this exam will be basic to adopt the preparation to the master center exam to a particular level of participants. So the third part is preparation to the master center exam, which covers all the basic topics. They are listed. There are 3 topics which will be common for both educational tracks. These are calculus, linear algebra and geometry, and differential equations. And there is one separate topic. This is physics for differential geometry and mathematical physics, or theoretical mechanics for algorithms of aided inertial and satellite navigational systems. What about the application? We don't require any kind of diploma, so we welcome bachelor students, bachelor graduates, or some past years bachelor graduates. So we welcome anyone who may be interested in the school's program. However, we expect the attendees to be fluent with some fundamentals of mathematics, like basic skills in calculus, algebra, differential equations, etc. For corresponding educational tracks, we expect attendees to have basic acquaintance with physics or theoretical mechanics. And surely, as well as all the courses are taught in English, we expect listeners to be able to attend courses in English. So the application is located on our website. That's a simple application form, and it's available till the end of June. The intention to make a report on the mini-conference may be expressed through the application form, as well as in further communication with your manager. In a week after the application, the potential attendee will receive further instructions, such as agreements, payment information, etc. And the technical information, as well as access to the online learning systems, will be provided after the payment. So here you can see the website, as well as the QR code for this website. It may be more convenient to use this method of communication. We also will be happy to answer your questions in the Telegram, and we hope to see you at the summer school. Thank you for your attention. As I can understand, so now we'll pass to the question section.
As far as I can see, there are no questions for the moment. We can wait for a couple of minutes and maybe some questions will appear.
I'm afraid they won't appear because there are 2 spectators, including me.
So as there are no questions, I think we can finish this, our open day for this program. Thank you very much.
Thank you very much. Bye-bye.
Bye.